Hello all, welcome to my channel. So I am starting today with second law of thermodynamics. In this, we have various statements under second law of thermodynamics. So I would be starting with Kelvin's statement today. So in this basically you should know what source is, what working substance is, what sink is. So first one, the source is actually used to provide some heat to the working substance. Now, whatever waste material is obtained from the working substance is given to the sink, and whatever be the useful amount is known as net work done by working substance. So we have three things. We get net work done from the working substance, which is the most useful one. Now, the Kelvin statement states that it is impossible to obtain a continuous supply of work from a body by cooling it to a temperature below the coldest of its surrounding. Now, let us take one example to solve this equation, this statement. So, we know that in a heat engine, the working substance here absorbs heat from the source, which is at quite high temperature. This is at high temperature, and this heat energy is being transferred to the working substance, and this working substance convert it into a mechanical work and rejects the rest to the sink. Whatever be the waste will be sent to the sink part. Now, it is very important to have sink because the presence of sink is essential for continuous conversion of heat into work. We cannot obtain continuous supply of work from a single body until or unless we are attached with a sink. So it is very important to have sink as the outcome here. Now, if I say that the temperature of source is equal to temperature of sink, then efficiency of this heat engine will be equal to 0. So therefore it is very important to maintain the difference in the temperature of source and sink. Therefore then only they will work. So this is about Kelvin's statement. Now we have Clausius statement. Now let's start with second one, that is Clausius statement. So it says that it is impossible for self-acting machine unaided by any external energy to transfer heat from a body at lower temperature to another body at higher temperature. This is actually opposite of what we studied in the Kelvin statement. This is the Clausius statement. It in this case you can see we have a source and we have a sink. Source is at high temperature again, the sink is at low temperature again. But in this case, we are making use of electric motor. This is actually an example of refrigerator. So in this case, we make use of electric motor, and you can see that work done is given to the working system. That means electric motor is doing work on the working substance. And in this case, the working substance extracts heat from a colder body, that is sink in this case, and rejects a larger amount of heat to a hotter body, that is our source. So, and an external energy agency is used in this case, that is the electric motor. So, no refrigerator can ever work without external supply of electrical energy to it. This is the Clausius second statement, second law of thermodynamics. So you must be clear with this. Now the third one is the Planck statement. The Planck statement says it is impossible to construct a heat engine operating in a cycle that will extract heat from a reservoir and perform an equivalent amount of work. That means this statement implies that the working substance working in a cycle cannot convert 100% of heat extracted into work. Some of heat extracted has to be rejected to the sink. This basically means that the work done by any working substance cannot be 100%. it can't achieve 100% efficiency. Like if you are up supplying working substance with 40 joule, so it will give off 35 joule and some of the energy will be lost to the sink. And as stated earlier, sink is required to work. So if there won't be sink, there won't be any energy. So some percent of energy will be lost to the sink. Suppose let it be 5 joule. So that's the Planck statement. It says that it is impossible to construct a heat engine operating in a cycle that will extract heat from a reservoir and perform an equivalent amount of work. That is 100% of heat can't be extracted from any working substance. So this is all about second law of thermodynamics. Let me discuss some of the applications of second law of thermodynamics. So the one application, as I earlier stated, is a refrigerator. Refrigerator work on the principle of second law of thermodynamics. You can consider any transfer of heat, expansion of gases. All types of expansion of gases come under second law of thermodynamics. Fourth can be diffusion of gases from one place to another. So that's all under the applications of second law of thermodynamics. I will start with the next topic after some time. I will start with reversible and irreversible process in the next lecture. Thank you for watching.